Hi, this is Margo. This is Sunday afternoon, August the 30th, 2020, and this is my weekly update for methane and Arctic sea ice and other climate-related items that I will be putting on YouTube. If you like what you see here and would like to see more of my videos, I do almost daily updates and post them for my private members on Subscribestar, and the link in the description box below, you can get to my Subscribestar page. So let's get started here. We're going to begin by looking at the NOAA methane data for yesterday, the 29th. This is for the 477/469 millibar reading. For the MET-OT-1 satellite in the morning, the mean or average reading was 1909 parts per billion. The high reading was 2416. In the afternoon, the mean was 1910, and the high reading was 2395. On the MET-OT-2 satellite in the morning, the mean was 1889. The high reading was 2420. In the afternoon, the mean was 1887, and the high reading was 2454. So it's this number that I'm taking from these pictures, the mean, and I've been tracking this on a spreadsheet since March of last year, and so I take the mean numbers for each of the satellite data and add them up and divide it by 4 and come up with an average for that level. And so the average for yesterday was 1898.75 parts per billion. So that's showing an increase over last Saturday, the 22nd, of 1.25 parts per billion. So here's the graph where it's been going up, and so here's our increase again this week. And so what we're seeing is since the data started over on basically March the 1st, from when I started tracking this, or this year it was February 29th. Since then, we've seen an increase of 22.25 parts per billion. Since March the 1st of 2019, we've seen an increase of 41.5 parts per billion. So we're in the middle of the time when methane goes up. It typically rises around the world about in June or July, after the summer heat sets in for the northern hemisphere, and it goes up and until about mid-October, and then it goes down for winter, and then it's not supposed to start going back up until June or July. But what we're seeing is that it started going up. We had a huge increase in February of this year, and so we didn't go down as low as where we started. So, you know, if you're always going up, the trend is up then. Now, I want to show you what's happened this week, and these are the numbers. This is the data that I report daily when I include the NOAA gives from each day. And so here's last Saturday, the 22nd, where it was 1897.5 parts per billion. So, and that was an increase, a sharp increase of 2.25 just for that daily reading. Then on Sunday it went up 0.5, On Monday it went up 0.25. On Tuesday it went down 1. These are parts per billion. On Wednesday it went up 2 parts per billion, so that was a sharp increase. On Thursday it went up 0.75. On Friday it went up 1. And then for Saturday it's a sharp decrease from Friday of 2.25 parts per billion. So if we had taken the reading from yesterday, we would have seen an increase of 3.5 parts per billion. But since it went down 2.25, it was a sharp decrease from Friday to Saturday. We're only seeing an increase from Saturday the 22nd to the 29th of 1.25. But since February, it's gone up 35.5 parts per billion. So this is really dramatic, and I'm going to keep tracking this and see what happens. And that's the only way we can really get data, is to do your own research. So now let's move on over to CAMS. This is Copernicus Atmosphere Monitoring Services. We're going to look at the data for Saturday. They do have the Sunday data up, but I'm going to focus on Saturday since the NOAA data is for Saturday, so we can have a better comparison if we just focus on those that one day. So I've got Saturday the 29th pulled up. I've got the Arctic view ready and surface level. Here's the color ledger at the bottom. Now this is where methane left off on Friday. We're seeing it pop off on Iceland here. We've been seeing all week Norway, Sweden, Finland, and northwest Russia has been totally covered up in these high methane readings. We've been seeing this high reading off the coast of Severnaya Zemlya, and it's been pulsing up and moving across towards Greenland and then out and around. Now this has been coming up since January in that area. We're also seeing high readings here throughout Russia, northern Russia, and they've got a lot of wildfires burning. So part of it is from that. They've got 2-meter temperature anomalies in the brown up here. So it's higher, the ground temperature or the air temperature there is higher than normal. So all of those factors will increase the methane. So with the higher temperatures and the fires, there could also be permafrost that's melting, and so that could be releasing a lot of methane. We're also seeing these higher background colors. We can see, like, from the dark green, this dark green is 1920 parts per billion, and then as it starts going up, it goes lighter. With each shade it goes up another 20 parts per billion. And so this chartreuse color is 2000 parts per billion. Remember, this is surface level that we're looking at. And then when you get up into the yellows and orange and reds, you're going up much higher. This dark brown color is, or reddish brown, the range is 2160 to 10,000 parts per billion. So we don't know exactly what the reading is, but we know what the range is. And if it's higher than what they can record, they'll show a white spot. It'll show white on the map. And I've been seeing that over here in China. There's a spot coming up over here that was in the white zone. So here we go. So the data is for Saturday, and the forecast runs Sunday through Wednesday. And the Arctic is still in the sun, in the sunlight, and the axis is, the North Pole is starting to tilt back away from the sun, so the South Pole is starting to get some sun, and or the Antarctic, and but right now we've got sunlight 24/7 up there. There's also been some storms. There's a cyclone that's turning around in the Fram Strait right now between Svalbard and Greenland, and there's going to be another system coming up this east side of Greenland that looks pretty intense weather-wise. That on Climate Reanalyzer, it's forecasting that it's going to clip this northeast edge and then head west across the just north of the coastline there, which will affect the thickest sea, what's left of the thickest sea ice right here. So that's forecast to happen. So we're in big trouble. So we're still seeing what's going on, and still seeing lots of methane coming up. And like I said, these background colors are higher. So this methane is coming up through the ice. Now remember, the ice is not well formed. There's a lot of open water between the ice, and so the sea surface temperature is higher than normal, and so the ice is melting from below and on top. And they're worried about these frozen clathrates that are in the sediments of the seafloor, that if the ocean absorbs too much heat and radiation, that those clathrates will start melting and release the methane. So I don't know what the source of this constant release is here from Severna Zemlya, but it's getting bigger, and it's it's not looking better. Now let's look at the North Pole view. We can see pretty much the whole northern hemisphere from the North Pole view. It opens it up. Here we go. So here's the UK, here's Ireland, this is Europe down here, here's Spain, here's North Africa across here. This is the Mediterranean down here. Here's Saudi Arabia, here's the Persian Gulf, here's India, it's here's China, here's Korea, Japan's over here. Here's the Kamchatka Peninsula in Russia, here's Alaska, Canada, Greenland, and then the United States starts at this line, and south here's Mexico, Central America, and northern South America. So we can see that it's filling back up in India. This is typical as we go later into the warming season, and also we're starting to see methane creep out over the coastline and coming up through the water here off the coast of China, and a little bit around India like that, but we'll see more and more like that. And methane is stored in the oceans, in the sediments of the oceans all around the planet, not just in the Arctic, but there are lots and lots of places that there are huge methane stores in the ocean, in the seafloor, just all over the place. And the problem with methane is that once it's released, well, it goes up really fast through the atmosphere because it's so light, but it breaks down into carbon dioxide, and so it hangs around, adds to the carbon in the atmosphere, and so it heats it up, it heats everything up, and as a result the atmosphere can be moister, and we'll see more clouds coming up over the oceans and coming up faster, and bigger clouds. We see the atmospheric rivers. The storms are more ferocious and more intense, like we saw with Hurricane Laura and Hurricane Harvey, and all these things. It has to do with the abrupt climate change and the runaway heating of the planet, and as the ice is melting, the Greenland ice sheet is deteriorating as well, and with that's causing all kinds of problems with the ocean, with the salinity and stuff. It's also changing the weight on the tectonic plates, and so we will be seeing more and more earthquakes as a result of the shift of the weight from one place to another as the ice melts. And with not Iceland, with the Antarctic, the same thing as the glaciers melt. So here's that white spot. If you look where my arrow is, watch. You see that popping up there? That's where the methane is higher than what it can be registered. That's in northern China. There it goes again. So here's the global view. Now we are seeing this darker blue come back. Now this is a lower reading. The darker blue is 1800 parts per billion. Now for the last couple of weeks we haven't seen much or any dark blue. We've seen this lighter blue, which is 1820 to 1840 parts per billion. We've been mainly seeing that, but we're still seeing that lighter blue in the southern hemisphere all around the Antarctic. We're also seeing releases around the coastline of the Antarctic, like here to the east of the Weddell Sea and over here also on the western peninsula. And also there have been a couple of earthquakes right at this tippy point of the western peninsula in the last day. We had a 4.9 yesterday. We had a 5.1 today. We just had a 6.5 earthquake here in the middle of the Atlantic Ocean right on the plate line. And so the plates are moving, and we can see evidence of it with the earthquakes like that. We can see it streaming off of Australia. New Zealand's coming back to life, and streaming off of South America as well. Now the U.S., it's we'd have to tune in a little closer here. Pardon me if I'm a little bit slow today. I'm not feeling that great. I was in a toxic environment yesterday, and I'm reacting to it, so it affects. I can't express myself quite as well as I should. Wherever you go, they're using these really toxic cleaners now, and it was obviously something that I had a bad reaction to, but it'll take a few days for my body to get it out. So I haven't loaded up this North America view. It'll take a couple of minutes. Now I'm a little surprised that we're not seeing more methane being released in the south, but I think it's because this area is in the blue zone, or cooler than normal according to Climate Reanalyzer. We've got Southern California is very high, and then coming up through the middle of the state and up, but it's gone way down, and it was really bad during the wildfire. Well, the wildfires are still burning, but they're gradually becoming contained, or being able to be contained. So we're seeing high readings up here in the Midwest and up here in the Northeast, especially on this East Coast line, and down here in Florida. Now this is typical. Well, these places are typical, but after a hurricane and lots of water, we normally see a lot of methane in the wake of that because of flooding and stuff. But it may take a few days for it to be reflected in the methane. So we'll just have to keep an eye on that. Now let's look at 500 HPA. And I'll refresh so we can have the correct color ledger. So this is similar level as what we saw on NOAA. So the most concentrated is here from China down to India. We've got reds from Saudi Arabia over through Africa, and some red spreading out across the Arctic and across Russia. Now, if we ran the movie, these reds would be moving. And we've got this dark green all the way to the bottom, and lighter green further south. We've got yellows and reds further south. So it's increasing, but it's increasing all around, not just in one place. Okay, here's total column. Let's refresh and get the color ledger. So here in this dark end, it's between 1920 and 2320 parts per billion. So total column is where they add up the methane in all the different levels and average it out. So, or come up with the total column reading. So we've got the highest reading over China. Here, this is where we saw that white spot popping up. I think that's in the Beijing area. And then India, and then we've got the reds here over the Persian Gulf and Saudi Arabia. And we've got some greens moving further south now over the Antarctic. So we've got higher readings showing up further south and over the southern hemisphere. So there's that. I'm going to take you through the rest of my slides here, then we'll look at sea ice. Here's the dust for today. This is from CAMS. These dust clouds from Africa have been coming across the ocean all summer long. Here's one that's made it across and now is headed up into the Gulf of Mexico. And here's another one that's well formed and it's coming across, and it's also going east. Here it's the smoke from the wildfires. This is the Arctic view. So look at how it's filling up in Russia. It's awful. It's awful. And we can see it on NASA Worldview. And it's sweeping out across the Arctic. And this affects the sea ice because when it rains or snows or the wind blows, which it constantly does up there, the soot and ash from the smoke falls down on the snow and the ice, and it absorbs the heat instead of reflecting the sunlight. It affects the albedo. There's less albedo, and so the sea ice will melt faster with that. Here's the smoke here from the fires in California. Here's the smoke. This is the global view, so it's quite a large area in Russia now. Here's Africa, here's South America, and here's the US. So this doesn't look like much in California compared to Russia especially, but it's a different terrain, and this is happening in very populated areas here in North America. So here we can see the smoke has trailed all the way across the United States and Canada and is drifting across the Atlantic, and There have been fires in Colorado and also in Arizona, and I'm not sure, probably down in Mexico, I'm not sure. Here's the total aerosols. This includes dust, smoke, sea salt, and sulfate. Here's the ozone layer. This is the Antarctic view, and where it's in this dark line, this is dangerously low. And we're seeing it's dangerously low. The purple blue is 200 Dobson units, and so it's dangerously low, huge areas. And then this blue is 175, and this darker blue is, I think, is 150. We could look and see. We can look and see just to make sure. I don't want to quote it wrong. Right, I was right. So the dark blue is 150, but the solid yellow is 300 Dobson units. That's considered to be healthy, a healthy level. But so most of the planet is thinner than that, from the chartreuse on down. Let's go back. So that's a huge area, and it reaches all the way up to South America. And if we ran the movie, you would see it moving and kind of morphing around. So we can see the whole continent is in a thin area. But that's typical towards the end of their winter down there, because they haven't been getting any sunlight, and it takes sunlight to make ozone, to make good ozone. Here's the North Pole, or the Arctic view, and we have an ozone hole over the whole Arctic, almost the whole Arctic Ocean, and it's coming down over Greenland and this Canadian archipelago, and over parts of Russia. So with it thinner like that, it lets in more radiation from the sun, and so again it'll heat up the water more, and it'll melt the sea ice more. So here's the global view. We just saw that too. So we can see it's huge areas that are in the greens, which is thin. Here's sulfur dioxide for today. This is the global view total column. We're not seeing any huge new releases or new high readings. The highest one we see right here is in Russia, and that's from the wildfires, and we'll also see a high reading here at Popocatépetl. Here's 500 HPA. I like this view because when you have like a volcano that goes off or an earthquake that's about to happen, well, if it's earthquakes, sometimes pockets of sulfur dioxide will be released as the rocks are moving, and it's released before the earthquake, and it can be an indicator of earthquakes. But with volcanoes, it shoots right up and likes to hang around at this 500 HPA, which is about halfway up in the atmosphere. Here's the East Tropic view. So the highest readings we're seeing right here over China. This is from pollution from society. It's coming back here in Kazakhstan, here over India, Saudi Arabia, and these Middle Eastern countries. This is from the oil production and pollution and so on. Now down here in South Africa, there's a bunch of mines. They've been mining down there for a long time, and we're seeing continuous high readings of sulfur dioxide, methane, and other gases down there too. Here it is at 500 HPA. Here's the Pacific view. So the ring of fire goes all around the Pacific Ocean here. And so we have Alaska's always got sulfur dioxide coming up because they've got a lot of earthquakes all the time. They also have a lot of volcanoes, and they can release sulfur dioxide as well. Here's Hawaii, here's Popo. Here it is at 500 HPA. Here's the West Tropic view. So here's North America and South America and everything in between. So here's Popocatépetl in Mexico. That's the big releaser right now. We're still seeing these higher readings across North America. This is as a result of the fires that have been burning in the West for the last couple of weeks. And we always see higher readings along this coastline of South America because there's a chain of volcanoes that runs down there, and they're giving off sulfur dioxide. And they're also on the Ring of Fire, and they have a lot of earthquakes too. Here it is at 500 HPA. So we can see it zipping right up to this level here from Popo. Here's the North Pole view. So we're seeing higher readings now drifting out across the Arctic. Here's the fires from the fires in Russia going all the way across here. And so the sulfur dioxide, when it rains or snows, with that, it makes the rain or snow acidic, and so that will help melt the sea ice. Also, sulfur dioxide will break down the ozone layer, as well as fires. The fires will break it down, the smoke. That's probably why we're seeing the ozone hole over the Arctic. Here it is at 500 HPA. Here's the South Pole view. And here it is at 500 HPA. Now I took some pictures of earthquakes this morning. There were 209 worldwide. This here's this 5.1 at the Shetland Islands. Now we had this one on the east side of Brazil. Normally we don't see them over here. Normally they're over on the west side of South America along the plate line. So it's kind of unusual to see one over here This is in the 4s range. This was 5s range north of New Zealand. They've been having some earthquakes down there. Here's a 5s range in the Philippines, and these other dots are 4s range, and that's a 3 range there. Here in the lower 48 there were 136. So we're not seeing any activity up here in the Pacific Northwest or Yellowstone, which is highly unusual, but on the weekends I kind of make a joke and say the earthquake makers are not at work on the weekends, like doing quarry blasts and things like that. So we definitely see a difference on the weekends, and I think that the quarry blasts can trigger earthquakes as well. Here's a larger one in Arkansas. We're going to look at that in a second. North Carolina is still rocking. Here in Southern California, in the Searles Valley Ridgecrest area, there were 13 today. So that's a sharp decrease from what we were seeing earlier this week. We got up to 44 a few days ago, and then they've been coming back down. Here in western Nevada and over into Mammoth Lakes, there were 56 today. So here in Arkansas, there was a 3.6 near Marked Tree, Arkansas. This came in last night at 7:34 p.m. Now this is in the New Madrid danger zone, the New Madrid seismic area danger zone. Normally we don't see them this big here, but we can, and so things are moving. Here at Sparta, North Carolina, about a couple of weeks ago, or about a week ago, there was a 5.1 up here. This has still been shaking, and we're seeing some microquakes here, and they're quite shallow, like minus 0.7, minus 0.3, minus 0.4, and they're 0.1 and 0.2 kilometers deep. So they're very shallow and very tiny. So here's this 4.6 on the east coast of Brazil at Tuipe. This came in at 3:44 this morning. There was this 4.7 off the west coast of Peru. Now see, it's right on the red line, right on the plate. Now over on this east side, the plate line that we have runs right through the middle of the Atlantic Ocean, so this is a long way off from that. Here in the South Atlantic, just north of this western peninsula of the Antarctic, was 5.1 at South Shetland Islands, and there was a 4.9 in the same place yesterday. So this one came in at 3:31 this morning. Here, just north of the North Island of New Zealand, was a 5.1, and this came in at 6:26 this morning. Here on the mainland of Japan was a 4.6 near Koga, Japan. That's northwest of Tokyo. This came in at 10:37 last night. Here in South Africa, in Malawi, was a 4.5. This came in at 9:06 p.m. last night. And here is the 6.5 that came in right before I started recording my show today. this came in at 2:20 this afternoon, right in the middle of the Atlantic Ocean on the red line. So here's this 4.6 in Brazil that I showed you, and so here's the 6.5. So this is showing a lot of plate movement around the planet. So those are all my pictures for that. Now let's move on to sea ice. Here's from Climate Reanalyzer for today. This is the sea ice and snow cover. For the Arctic, we can see the Baffin Bay is clear. We can see it's thin on this east coast of Greenland, and you can see the darker areas. This is where the ice has been churned up by the storms and cyclones that have been working on this northeast edge. It's also we've had some rain and storms up here on the northern part as well, and you can see it getting darker. That means it's less concentrated and breaking apart. And even at the North Pole, you can see it's a little bit darker. The thickest sea ice is still here, just north of the Canadian archipelago. Now here in the Baffin Bay, we've got some ice that's kind of hanging on, but it's collapsing. It looks like a tail. It looks like a scorpion tail to me, and but it's thinning, but that's where we're at today. And the ice you see coming out through these tributaries in these Canadian archipelago is ice that's flowing out from the thick sea ice. It's not refreezing yet. So let's go back, starting on Sunday of last week, or last Sunday when I did my show. This is where we were at with sea ice. So it hadn't, this part of the Beaufort Sea had not cleared out yet. So here's Sunday, there's Monday, Tuesday. You see big difference there. Wednesday, Thursday. Oh, wait. I gotta look at the days. Wednesday, and this is Friday. Climate Reanalyzer didn't update on Thursday, so I couldn't get a picture. So here's Friday, here's Saturday, and here it is today. So it's just shifting and kind of moving around, and the wind from the cyclones is also moving the sea ice. So you might see it coming closer to the coastline. It's not because it's refreezing, it's because the wind and the waves have moved it around. And the wind and waves can spread out the ice so that it can be measured as it can be measured as extent, but it's quite thin, and they don't talk about volume very often, but we're at the lowest point on volume, according to Sam Carana. So here's the sea ice thickness from the U.S. Navy model for today. Here's our color ledger over here. The dark purple is about 1 meter thick. The dark blue is 1.25. This aqua is about 2 meters thick, and as it goes into the darker aqua, it gets thinner. The lavender is about 0.5 meter thick, and it keeps getting lighter as it gets thinner. So let's zoom in. So here's where we're at. So we see, now there used to be more of a hole around this North Greenland coastline. We can see the ice is kind of piled back up there. It's piling back up. That's the wind is, and the waves are moving it over. But it's not, doesn't look good. When you look at it, it doesn't look good. We still have the hole around here in the Canadian archipelago. You can see the thicker ice where it's streaming out away from this thick sea ice here, and it's just coming apart and breaking down. We're seeing dark blue here, so it's breaking down here. So, and this Beaufort Sea, it's collapsing here. It's quite thin west of this 80-degree north latitude, and we still have some very thin ice in quadrant 1 and quadrant 2. I've numbered these 1, 2, 3, and 4 just for my own reference. So they'll count this as extent even though it's quite thin. They count every little crumb, even if it's just a little skim on the water. Here's the 30-day animation set up by the Navy. It goes back 3 weeks with the data and then forecasts forward a week from now. So it ends on next Sunday, September the 6th. And it starts on, let's see, the 8th. Yeah, it starts on August the 8th. So let's zoom in and watch this go. So you see the where the ice had pulled away earlier in the model, and then you can see it kind of being pushed back down around the coastline. And you can actually see it flow out, see it moving and flowing out without it melting down that much here from this thick ice. So typically the melt season ends around September 20th, and then the refreeze starts when the sun goes down in the North Pole. But what we've seen in the last couple of years is that it continues to melt into October, and it's hard for it to refreeze because the temperature of the water is so much warmer than it should be, and the water underneath the ice is warm, and so it's hard for it to refreeze. So here we're on the last day of the animation, so the 6th. This is where the model shows will be. This white means that the sea ice is gone. It's just little pieces. And then the next thing, like the next day or two, it'll be nothing. It'll be this gray color where it shows no ice. Same thing here. Looks like this Beaufort Sea is going to be opening up. There's a little bit thicker ice hanging on here. It kind of parallels the Alaska and Canadian coastline there, but it's collapsing inside here. So are we going to go ice free I don't know. I mean, we're just going to be watching these models. I show this every day on my daily reports as well. But we're already seeing the effects of a blue ocean event. It doesn't have to be completely ice-free for us to have some awful effects. It's already started. So there's that. Let's move on. Here's Climate Reanalyzer for today. Here's the maximum temperature, and so now we're seeing greens around Greenland and all across the Arctic. There's some blue over here on the west side in the Chukchi Sea and the Bering Sea. I mean Beaufort Sea. I didn't mean to click that. I gotta keep clicking to get it all around. Now this is the air temperature. So here it is around the globe. A lot of areas are in the white zone, which is between 40 and 50 C. Here's 2-meter temperature anomaly for today. We can see it brown around the Siberia coastline and coming across the Arctic. So that's, 5 to 10 degrees higher than normal. And Greenland is in the brown, and the Baffin Bay, and see Russia is getting into the dark brown there. Now look at North America. There's a lot of blues, so that could be why we're not seeing as much methane down there. We've got a lot of reds in the Antarctic. That's higher than normal. So the Arctic is up 2.2 C higher than normal, and the northern hemisphere is up 0.8 C higher than normal. Here's precipitation and clouds for today. So the storm we've been watching, or the cyclone, it was hovering over Svalbard, and then it moved over to this northeast coast of Greenland, and it's just kind of churning there. But there's another system that's going to come right up. The model shows right up between Greenland and Svalbard, and then head due west. Here's the sea level pressure. So this is 989 millibars. So the lower the millibars, the more destructive it is, because it usually indicates a higher wind speed. Here's the wind speed in knots. The green is about 27 knots. So that's, about 30 to 35 miles an hour going around there. So that's pretty good wind. It's hard to see the jet stream. But we can see it looping around and splitting off. And here it's all split up in the southern hemisphere. Here's sea surface temperature anomaly. They updated it to yesterday, and so these we can see that all around the ice edges it's at least brown and into the reds and the pinks. So when you start going into the tan, it's about, and into the brown, this color right here is 2C higher than normal. This reddish brown is 4C higher than normal. The pinky color is 6C higher than normal. We're seeing that here in the Kara Sea and in the Laptev Sea. Look at it around Greenland and here in the Hudson Bay, and it's not looking good. The oceans are heating exponentially. So Northern Hemisphere, North Atlantic, and North Pacific are all 1C higher than normal. And overall worldwide, it's up 0.6C higher than normal. Now, here's the National Snow and Ice Data Center for sea ice. Here's daily. Here's concentration. I like the blue marble view. So where it's darker blue, that's less concentration. And it means it's thinner too, and it's not as packed together. Here's their chart for Arctic sea ice extent. Now, extent does not reflect volume or thickness. It's just like wherever there's a little crumb of ice. And this blue line is this year. The dotted line is 2012. And we're still going down, but we had been below 2012 for a long time, and then we crossed the line around the end of July, and it's showing that we're still higher than 2012, but that's, you know, it's deceptive because in 2012 the sea ice was much thicker. So there's that. Here's the Greenland ice sheet where it's melting. Here it is where it's melting today. The salmon color is, they're experiencing melt in the salmon colors or color. And here's the cumulative melt days this whole year. And it correlates to this chart on the right, and you can see it melting even in the middle of the ice sheet. Look, even on the inside it's melted. Here's the melt extent for this year. The red line is this year, and the dotted blue line is the median range. And so we can see for most of the summer it's been way up higher than normal. And we jumped up again in August up to around 20% melt extent. Then it went down and now it's jumped back up. That's about 5% right there. Okay, now let's move on to NASA Worldview. This is sea ice concentration for today. I will refresh and get the latest data. So where you see the colors and it shifting down through the rainbow, you got more melt. It's less concentrated. So I took away the clouds, and this is where we are right now. So we've got a large area here around the Russian side that's totally ice-free. It's totally ice-free all around the Russian coastline. It's ice-free around the Alaska coastline in Canada here, and Baffin Bay is clear, and it's melting, and this is going to be deteriorated by the cyclones coming through when it comes up through this Fram Strait. And we've got heavy melting and deterioration going on north of Greenland and on this eastern side, and up here this is from the storms, and then it's still deteriorating a lot on this northern edge, and here in the Baffin Bay it's breaking down. So let's go back. So last Sunday was the 23rd. So here we were last Sunday. So you already see a difference. This hole had not completely opened up yet. So watch as we click through where we've been this week. So here's Sunday. Here's Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Let me refresh. Here it is today. So we saw it's just been coming down, coming down, coming down around the edges, and now this area north of Greenland is really being affected. So let's turn, oh, why did I turn that off? Let's turn the clouds back on. So when we zoom out, you can see all the smoke in Russia, and you can see it pouring over, streaming. It's getting caught up in the clouds and the wind, so it's making the clouds darker colored than what we normally see. So here's our storm right now. But there's a series of storms that are going to be coming in and up. So let's zoom in and see what we can see here. So, like I said, you know, it may show ice along the coastline, but it's not healthy ice. It's just the pieces that are kind of shoved back up. So we're having to look through some clouds too. That's a pretty good view. But see, there's a lot of open water. Here's Ellesmere Island. Here's clouds. So we're looking through a thin layer of clouds, but this is all broken up. See? So the thickest ice is right in through here. And it's flowing out these tributaries. We can't see it because of the clouds right now, but it's moving out. Here's the Beaufort Sea. We can't really see the collapse because of the clouds here. there's some pieces. See, they'll count that as extent. Oh, I think I wore out my voice. Here's some ice. It's so thin. Just lacy and fragile. Here's the ice edge up north. Here's, this was like the different colors that we saw. But you can see there's a lot of open water there. And it's just pieces of ice, and it's not well formed at all. It's quite thin. Here's the ice edge. And that's about all we can see because of the clouds. Here's some more ice edge here on the right. So there it is. So there's that. Let's take a peek at some earthquakes now. Here is that 6.5 that just came in. So I think I've showed what I want to show on earthquakes. One more thing I want to do before I end the show. I want to show the forecast on these storms for the Arctic. Precipitation and pressure. Let's go to the beginning of today. Now I'm gonna zoom out so I can get the whole thing on here. So the date's up here. It's kind of hard to see. It makes it really small. But I wanted to be able to toggle it. And so here's where it was at the beginning of today. Here's this system in the Fram Strait. Cyclone, we can call it a cyclone. 986 millibars with rain and snow. So let's run this. So here it went up around Svalbard, and it's just kind of churning, and then it moves up north and then kind of comes over. But in the meantime, look at this big thing coming in, and another one, and this is rain, and this is 987 millibars, and then it ends up going over the thickest sea ice. So that's what's coming up. We've got all that in the next 10 days. So here it comes. This is on the 3rd. Here comes a bunch of rain. And then the 4th. And here it is on the 6th, where it makes a left turn and curves right down over the thickest sea ice with a bunch of rain and snow. So it's not looking good. So there it is on the 7th, where it's coming down over that thickest part. And then that's the end of the model on the 9th. So next week on my show, we'll see where we're at. Next week will be September the 6th. So we'll see how accurate their model was. Now I'd like to finish up by continuing to read from Hosea. I'm in the process of reading and recording all these prophetic books of the Bible from the Old Testament, because these prophecies apply to our time, because I believe we are in the end times. And the more we're aware of it, and more we can see from the old prophets, the better prepared we'll be. And we need to prepare spiritually. More than anything, we need to prepare spiritually. Hosea chapter 8. Set the trumpet to thy mouth. He shall come as an eagle against the house of the Lord, because they have transgressed my covenant and trespassed against my law. Israel shall cry unto me, My God, we know thee. Israel hath cast off the thing that is good, the enemy shall pursue him. They have set up kings, but not by me. They have made princes, and I knew it not. Of their silver and their gold have they made them idols, that they may be cut off. Thy calf, O Samaria, hath cast thee off. Mine anger is kindled against them. How long will it be ere they attain to innocency? For from Israel was it also, the workman made it. Therefore it is not God, but the calf of Samaria shall be broken in pieces. For they have sown the wind, and they shall reap the whirlwind. It hath no stalk, the bud shall yield no meal. If so be it yield, the strangers shall swallow it up. Israel is swallowed up, now shall they be among the Gentiles as a vessel wherein is no pleasure, for they are gone up to Assyria, a wild ass alone by himself. Ephraim hath hired lovers. Yea, though they have hired among the nations, now will I gather them, and they shall sorrow a little for the burden of the king of princes, because Ephraim hath made many altars to sin. Altars shall be unto him to sin. I have written to him the great things of my law, but they were counted as a strange thing. They sacrifice flesh for the sacrifices of mine offerings, and eat it, but the Lord accepteth them not. Now will he remember their iniquity, and visit their sins. They shall return to Egypt. For Israel hath forgotten his Maker, and buildeth temples, and Judah had multiplied fenced cities. But I will send a fire upon his cities, and it shall devour the palaces thereof. Hosea chapter 8. Well, I think we can see some parallels here. So, if you haven't given your life to Jesus Christ and repented of your sins and asked Him to come in and be your guide and your protector and your Lord and Savior, I recommend you do it now. So I'm praying for everyone. We're in dark times, and it's going to get darker. And the only protection we can have is spiritual, from God and Jesus and the angels. So until next time, God bless you. I love you all. Go in peace, and I'll talk to you soon. Goodbye.